Um, Good morning. My name is Moses. Today I'm going to be talking on one of the applications of calculus, which is local and absolute extreme values. So today I have a question on the board, which is saying find the local and the absolute extreme values of the function. This is a function f of x 3x cubed negative 6x squared plus 9x plus 1 within this interval. Now, let me tell you, to remind you what we mean by absolute and extreme values. It's just the same thing as finding the maximum value or the minimum value of your function. You know, this is a cubic expression, so you can imagine when you plot this graph, you're going to have something like this, you know. So the question is actually asking us to find where is this maximum value, what's the x value of it, and what's y, and the minimum of it. That's what we want to look for. But it has to be within this interval between 2 and 4. It can't be outside it. So you're going to be, maybe this is 2 and this is 4. We can't go anything behind after. So we got to use our knowledge of calculus, differentiation. So what we do now is basically we're going to find the derivative of this function. We now set it to 0 because we know at the maximum point, which is a critical point, the derivative will be 0. So when you set it to 0, we try to find the x value, and we also find the corresponding y value. So whichever of these x value, the y value is the greatest of all, would be our maximum, and whichever one is the lowest would be the minimum. So let's go. So f prime, which is my derivative, would be 3 times x squared negative 12x plus 9. Now, at the maximum value, the f prime of x would be 0. So I'm going to find f prime. I'm going to set it to 0. So it implies this is equal to 0. 3x squared negative 12x plus 9 equals 0. So when I factorize it, I'm going to have this factorized to give you, I can divide everything by 3. So it gives me x squared negative, divide this by 3, that gives me 4x plus 3 equals 0. So find two numbers such that they multiply, and then it's going to be x. Find two numbers when they multiply, it gives you 4. And when they multiply, they give you positive 3, and when they add up, it gives you, I think it's going to be actually 3 and 1, negative 3 and 1. So you see, 3 times 3, negative 3 multiplied by negative 1, it gives you plus 3, and when you add them up, it gives you, so we're right. So the zeros of this function will be x equals at 3, or x equals 1. So now what we do next is we're going to plug in these values of x to find the corresponding y value of it. So I'm going to say f function of x instead of s. Now I'm going to have when x is 3, what is y? So when I put when x is 3 into this function, it's going to give me 3 raised to power 3, negative 6 multiplied by 3 squared plus 1. Plus 9, I get 3. Plus 1, I'll get it. I also need to get for when f of, when x is 1. So I'm going to have x 1 to the power 3 negative 6 multiplied by 1 to the power of 2 plus 1 plus 1. So just to save my time, it's going to give me, when x is equals to 1, I'm going to have it as f of 3. I should have 1. So I'm going to have 1 here eventually. When x is equals to 1, this is minus 1 minus 3, 6. 6 that's 5 plus 9. That's 14 plus 8, that's 15. So I should have it as f of 1 is 15. Okay. Now I also need to test this point also, so I'm going to try to find f of 2. So whichever one gives me the highest of all this one would be my maximum, and whichever will give me the lowest would be. So I also try to find f of 4. So plugging in 2 into this expression, into this function, I will be having it as 3. Given 3, and plugging in 4, I will be having it as 5. But remember, this is an interval. So if you look at it within the interval of 2 and 3, just imagine you're trying to consider when x is 2 and when x is 4, maybe somewhere here. So anything beyond 2 that is negative, that's 1 to negative infinity, or anything after 4, maybe from 4.1 to positive infinity, we're not going to consider this value. So that makes my 1, which is less than 2, it's not going to be part of our interest. So what we're going to be looking at is 1 when x is 1, when x is 2, and when x is 3. Among all these 3, you can see that the highest of them is 5. So this is going to be my maximum. And the lowest among these 3 is 1. So this is going to be my minimum value. So the question asks, find the local and absolute extreme values of this function. So the maximum value, or the minimum extreme local extreme value is 1, and when it is maximum is 5. So that takes us to the end of the question. If you have any problem, just contact me at my email, moses2real at hotmail.com. This is actually one of the questions in the review questions. The review question is chapter 4. This is question number 1. Thank you.